Okay, imagine this, you're cruising at 50,000 feet over the North Atlantic, sunlight blazing through the cockpit windows. Suddenly, out of nowhere, a wall of shadow slams into you at 2,000 miles per hour. The temperature plummets. The sky turns midnight black. And you're flying straight into the heart of a celestial phenomenon that's equal parts terrifying and awe-inspiring. This isn't a sci-fi movie, it's NASA's actual eclipse chasing mission. But wait, why are they doing this? And what's really at stake here? Let's unpack this wild story /n/n. First off, let's get this straight. NASA isn't just joyriding in a souped-up Cold War bomber to take pretty pictures. They're hunting for answers to one of the sun's biggest mysteries. See, the solar corona, the sun's atmosphere, is millions of degrees hotter than its surface. That makes zero sense, right? It's like if your toaster's heating coils were colder than the bread it's burning. Nanoflares, these tiny magnetic explosions, might be the key. But here's the kicker, we can't study them properly from Earth or space without a total eclipse. So NASA's flying into the moon's shadow like some cosmic race against time, /n/n. Now, let's talk about the plane itself. The WB-57? That's a 60-year-old bomber design originally built to deliver nuclear strikes. But instead of bombs, they've stuffed it with cameras that shoot 400 frames per second. There's something poetic about repurposing a weapon of mass destruction into a tool for discovery. Personally, I think that's way more compelling than any moon landing conspiracy theory nonsense. But here's what really fascinates me, why fly at all? Can't we just use satellites? Well, yeah, but the data they'd collect would take years to transmit. This mission? They're literally banking on outrunning the moon's shadow to capture terabytes of data in minutes. That's engineering insanity, and I love it /n/n. Let's zoom out for a second. Did you know only 0.000 something% of humans have seen a total eclipse? It's this ultra-exclusive cosmic club. But NASA's mission reveals something deeper, eclipses aren't just spectacles. They're scientific goldmines. The 1923 Navy biplane mission failed. In 1973, Concorde chased an eclipse for 74 minutes. Now we're here, flying modified bombers to study plasma loops. This isn't just about the sun, it's about humanity's escalating obsession with understanding our place in the universe, /n/n. But wait, why should you care? Because those nanoflares? They're not just academic. They fry satellites, knock out power grids, and endanger astronauts. We're talking trillions in potential damage from space weather we barely understand. So when some genius figures out how to predict these eruptions using eclipse data, suddenly this mission becomes our first line of defense against cosmic chaos /n/n. Here's my favorite detail though, the sensory experience. Picture flying through an eclipse at 50,000 feet. No clouds. No horizon. Just this alien darkness swallowing you whole while your instruments start freaking out. It's not just science, it's a full-body encounter with the universe's raw power. That's why even 0.0001% of humanity having witnessed this matters. Because when you see reality get rewritten for 3 minutes, you realize how small we are. And how brilliant. Because we built machines to chase shadows across the sky /n/n. So next time you hear about an eclipse, don't just look up. Think about the billion-dollar plane screaming through the stratosphere, the ancient bombers turned into observatories, and the trillion-byte data bursts that might one day save our power grids. Because the real story isn't just about the sun. It's about us, this weird, stubborn species that won't stop chasing cosmic secrets, one shadow at a time.